Hi. Your homework tonight is just to watch this video, take notes in your notebook. It's going to be around page 34. It'll start with powers. And just to remind you, if you're not on page 34, the last thing I believe we entered in our notebooks was about page 32 on integers and graphing. So page 33, you're either going to add in one of those modules, because we're starting a new module and a new chapter, and so that's going to be on page 33, and I'll either give it to you today, or you can just glue it in the next day, depending on how much time we end up with. Okay, so this is our page for our module table of contents, module 3, chapter 6. But today's notes are going to be on page 34, or the one that's right after that, and this is lesson 6.1. So we're in chapter 6, lesson 1. And it's all about powers. Not superpowers, but mathematical powers. So if you're doing your Cornell notes where you're asking the question, how do I write and evaluate? We've seen that word before. Powers. You're going to write them, you're going to evaluate them. It's kind of cool. So for example 1, if you saw write 5 to the second power, that's how that's read. This is called a base, and this is called an exponent. And if it says write 5 to the second power as a product, you know, product is the answer to a multiplication equation of the same factor. So 5 to the second power, all it means is 5 times itself, just 2 times, because it's got the power of 2. Now let me clarify, this is not 5 times 2. This is not 10. It's 5 times itself, so it's 25. But a lot of beginners assume that you just multiply these two. It's not adding like 2 groups of 5. It's saying multiply this by itself, multiply this base by itself 2 times. If this exponent were a 3, it would be 5 times 5 times 5. Okay, so what this is 5 times 5, which is 25. We just found the value, but this is an example. Then find the value. Okay, so product of the same factor, here maybe I'll underline that. Okay, that is 5 times 5. And then find the value, that is 25. The value of 5 to the second power is 25. All right, so then you're either going to glue this in right now at home, or if we had time, I had you glue it in, and it looks kind of like this. Doesn't have to be perfect. Okay, we'll just glue that in right there, and we'll do some more practice. I wanted to glue this in so that you didn't have to write all these, and the table's kind of done, and we'll save some time. So what this is value. 6, the expanded expression is 6 times 6 is 36. But written as a power, if you saw this first, it would be 6 to the second power. And of course, expanded expression is 6 times 6. And what we say is 6, this isn't working as well. 6 to the second power, or the power of 2. And you know what you can also call it? 6 squared. And I'll just explain that briefly. If you notice a multiplication table, 6 times 6, 36. What if we did 5 times 5? Oh, 25. 4 times 4, 16. 3 times 3, 9. Maybe you noticed what I noticed. Okay, whenever it's multiplied by itself, we have this little pattern. these are all called square numbers because they're derived from the same base multiplied by itself, you know, with 2 to the power of 2. 5 times 5, 4 times 4, 3 times 3. So these are all called squares or square numbers. Like this is not square because it's 10 times 4 or 2 times 20 or 5 times 8. We didn't multiply anything by itself. So these are non-squares, but these are all squares and on and on and on because of course there's no end to numbers, so there's no end to squares. And the base in this situation is 6. And how many times does the base appear? Oh, twice. So I'm even going to make it like tiny to remind us the exponent is the tiny little one up in the air. You know, since we're beginners, we'll just go ahead with that. Next, we'll do 3 times 3 times 3. Of course, that's 27. This is not 9. It's not adding 3 groups of 3. It's 3 times 3 is 9, times 3 is 27. That written as a power, and you can go in any order here. I just kind of keep doing this as a pattern. That is 3 to the 3rd power, and that's what we would say. 3 to the 3rd power, or yeah, to the power of 3, either one. And this is also called 3 cubed. Squared and cubed are the only ones that have like those optional names. The other ones are just straightforward. So let's keep going with 3 cubed. The base, you know, is 3. And how many times does it appear? Oh, 3 times. So that's the little exponent. You multiply the base by itself 3 times, right? Well, look at this one. 2 times 2 times 2 times 2. So there are 4 of those little bases. The base is 2. How many times do we see it? Oh, 4 times. So that is 2 to the 4th power. What we say is 2 to the 4th power. You can also say power of 4. Okay, and let's take a look at this one. Oh, they're fractions. That's okay. We still do fractions in the same manner. Let's see. What number is repeatedly multiplied? So the base is 1/5. How many times do we see it? 3 times. No, 3. It's 1/5 cubed, right? So written as a power, this is 1/5. Oops. 1/5, and we'll go like this to really show it. Put that in parentheses, cubed. So how we say that is 1/5 to the power of 3. You can also call it 1/5 cubed. All right, and then this last one, 4/10 times 4/10 times 4/10. 64 thousandths is our evaluated expression. So that's like the answer, you know, what it equals. And what that does equal is 4/10. Now, I don't mind if you use a calculator. If I'm remembering right, I'll have to double check. Calculators are going to be allowed. And I'm just double checking to show you. I want to demonstrate this so you know where this came from. 0.064 times, and by the way, you don't have to do the 0 point. I can just do times 0.4 times 0.4 equals, oh, that's not right. Let's look again. 0.4 times 0.4 times 0.4. Here we go. Sorry, I think I forgot to hit equals after the second one. So I'm glad I did model that, and you can see correctly how to use your calculator in that way. So 0.064 is our answer. This is the one that was repeated. How many times was it repeated? Oh, 3. So it's cubed. So we would write 0.4 cubed, or to the 3rd power. 0.4 to the 4th power, or power of 4. You could also say 4/10 cubed. Okay. And then we will practice more tomorrow. That's good for homework tonight. Bye-bye.